temperature have different meanings. How? I am Arwen Torres to help you discover their differences. For this webinar, we are to differentiate heat from temperature, define terms, specific heat and latent heat, determine temperature and phase changes, discuss methods of heat transfer. Temperature affects our lives in many ways. We experience temperature as the hottest and coldest of an object. But scientifically, temperature is a measure of an average kinetic energy of a particle in an object. We are aware of thermometer. This is a device by which temperature is being measured. There are 3 scales that temperature can be calibrated: Fahrenheit, Celsius, and Kelvin. You can convert from one scale to another. Why do our hands get warm when they rub together? Kinetic molecular theory assumes that matter is composed of many tiny particles that are always in action. Thus, the particles have both potential and kinetic energy. The sum of the potential energy and kinetic energy of the internal motion of particles is called the internal energy. Heat. It is the internal energy that is transferred from one object to another as a result of difference in temperature between two objects. The unit for heat is what we call joules. A more common is what we call calorie. Remember that 1 calorie is equal to 4.186 joules. When heat is added to a body, the following effects may be observed: rise in temperature, change in phase, change in size. Change in temperature. Specific heat is the amount heat needed to change temperature of a unit mass of a substance by 1 degree. It is denoted by small letter c and its unit is joule over kilogram, which is degree. Or it can be with this formula, we can determine how much heat is needed to change the temperature of a body. For example, how many calories of heat are needed to raise the temperature of 75 grams of water from 20 degrees Celsius to 80 degrees Celsius? Knowing that specific heat of water is equal to 1 calorie per gram Celsius degree. Heat needed is equal to mass times specific heat of water times change in temperature. Substituting the given will be 75 grams times 1 calorie per gram Celsius degree times 80 degrees Celsius minus 20 degrees Celsius. Canceling out the gram and degrees Celsius, will be 4,500 calorie. Vaporization is the change from liquid to gas. Latent heat of vaporization is the amount of heat needed to change a unit mass of a substance from the liquid state to the gaseous state at constant temperature. Latent heat of vaporization is commonly represented as LV. The latent heat of vaporization of water at 100 degrees Celsius is about 540 calorie per gram, or 2.26 times 10 to the 6 joules per kilogram. Fusion or melting is the change from solid to liquid. The latent heat of fusion is the amount of heat needed to change a unit mass of a substance from the solid state to the liquid state at its constant temperature. Latent heat of fusion is normally designated as LF. The latent heat of fusion of ice at 0 degrees Celsius is 80 calories per gram, or 3.35 times 10 to the 5th joule per kilogram. Sublimation is the change from solid to gas without passing the liquid state. The heat of sublimation is the sum of the heat of fusion and heat of vaporization. The heat of sublimation of water is 620 calorie per gram at 0 degrees Celsius. For us to get the heat required, we'll make use of the formula. Where M is the mass and L is the latent heat. How many calories of heat are needed to vaporize 500 grams of water at 100 degrees Celsius? Heat needed is equal to mass times latent heat of vaporization of water. Substituting the given is equal to 500 grams times 540 calories per gram, cancelling the gram, will be 270,000 calories. Substances expand when they are heated or contract when they are cooled. The changes in length, changes in area, and changes in volume when its temperature changes from TO to TF are given with the following formulas. These three signs are the coefficients of the linear expansion. A glass flask is completely filled with 200 cubic centimeter of mercury at 15 degrees Celsius. If it is heated to 85 degrees Celsius, how many cubic centimeters of mercury will flow out? Change in volume is equal to the product of coefficient of linear expansion, initial volume, and change in temperature. Deriving the formula or deriving the given will be 182 times 10 to negative 6 per Celsius degree times 200 cubic centimeters times 85 degrees Celsius minus 15 degrees Celsius. Cancelling the Celsius degree will be 2.548 cubic centimeters. There are three mechanisms by which heat is transferred: conduction, convection, and radiation. Conduction is heat transferred by molecular collision without gross motion of the body through which heat is transferred. Convection is heat transferred by actual movement of fluid. Radiation is heat transfer by electromagnetic waves. From this discussion, we integrate physics in our daily lives. I'm Arwen Torres of BS Pharmacy from Our Lady of Fatima University. Thank you.